Greetings, friends. In this video, we're going to begin our investigation of quantitative research methods, and we're going to start by taking a look at what we call descriptive statistics. In subsequent videos, we'll be taking a look at inferential statistics, but in this video, it will be descriptive stats. And descriptive stats are pretty much what they sound like. They're ways to describe particular data sets, and there's a number of different categories that are commonly associated with descriptive statistics. One is called the measure of central tendencies, which are pretty much what we think about when we think about averages. This goes way back to your middle school days when we talked about mean, median, and mode, and we'll talk a little bit about those measures of central tendencies. Another important part of descriptive statistics is what's called variability, and the most well-known variable statistic is what's called standard deviation, and we'll be taking a look at that as well. But basically, you can do descriptive statistics just very simply by describing, literally counting the number of particular individuals in a particular category in a data set. And oftentimes, at the very beginning of a research piece, you will see some kind of a descriptive of the individuals who are in the study or their years of experience or ethnicity, so on and so forth. And when you describe those statistics, the best way to do that is in the form of a table. Now, sometimes you'll see in somebody describing the participants in a study, somebody actually using a narrative and just writing those numbers out in a sentence. And that always is a little bit difficult to get your head around whenever you see that. So a table like this is very helpful to be able to communicate that data. This is the proper APA formatting for a table. You see there are only 3 lines, 3 horizontal lines that are used. 2 lines are used to separate the heading from the data that is in that table. So the parts or the elements of a table in APA formatting are the table number, you number the tables 1, 2, 3, 4, and so on. A descriptor that talks about what's in the table, the heading, and then the data itself goes between the second and third line. Under the bottom line, any notes that you might want to include. Another kind of descriptive statistic is a measure of central tendencies, or what we normally think of when we talk about averages. This is the mean, median, and mode. The mean is the arithmetic average, where you add up the numbers and divide by the number of numbers. It gives you the mean. The median, the middle number. The one that's used very infrequently is mode, the number that appears the most often. But it's these top two that we normally think of when we think of averages. And those are important differences between ways of communicating average. So if you ask, for example, what the average American makes, well, there's a couple ways of doing that. One is to just count up all the income, or add the income of everybody in America and divide it by the number of people, and that would give you the mean income. But the mean income, any kind of an average, especially an average when calculating population of these salaries that people make, or the amount of money people make in a population, is they are significantly impacted by outliers, by people who make significant amounts of money way out here on the extremes. So oftentimes what you'll see is what's called median income, or the income over which and underneath which half Americans make. So half the Americans make less than $49,000 a year, half the Americans make more than $49,000 a year. That gives you an idea of the median income for individuals in America. Another powerful descriptor is what's called the measure of variability, or standard deviations. And standard deviations are arrived at in a number of different ways. And we're going to start in this film by talking about how data is collected and how that ends up being into a bell curve. And then from the bell curve, we'll talk about how that you can use the statistic of standard deviation to help better describe the individuals that are in a data set. So let's say that we had a test that we had given a group of people, and these are the scores that they achieved on those tests. If all things were being equal, and you collected and organized those scores, you would come out with a distribution that looks something like this. And this distribution then would organize all the scores, and all things again being equal, most people would achieve an average score, and there would be some people who did quite well and others who didn't do quite so well. And so you normally end up with this kind of a distribution. People gathered more towards the middle, and then there's the extremes on the high side and on the low side. And this is called a bell curve, and called bell curve for obvious reasons. It looks like a bell shape, upside down bell. Now, you don't need to have all the scores in a sample in order to be able to arrive at an understanding or an idea of what that bell shape might look like if you were to collect all the scores. So let's say that you were wanting to know how a particular population group scored on a particular kind of an examination. Let's say the sample that you, or the population group you wanted was all fifth graders in the Central Valley, and you weren't able to have access to them, but you were able to get a cross-section at population, and you had just a select number of those scores. Well, the bell curve theory then would suggest you'd be able to infer this kind of a distribution, even though you only had a few of those scores that you're able to collect. So the bell curve is a way to understand the shape of a data set, of all the elements in that data set, just by sampling a few elements, a few of those representations from the sample. Another way to think of how that distribution occurs is to take a look at this bean. It's called a bean machine, and what it is a machine that actually randomly distributes beans as they come down this device. And you can see that at the very top, at each time a bean can go one way or the other, left or right, left or right. And if these beans were perfectly balanced, they would just randomly go here, then they'd be here or here, then here or here, then here or here, and so on until they came down. And you can see that at the end, given the randomness of this device, that beans will collect still along this kind of a distribution, this bell curve kind of distribution. And that's surprisingly how many kinds of distributions distribute themselves. And holds true for beans, and also holds true for scores on tests that are given to adults and to children alike. Now, as you would imagine, not all data sets are equally distributed. Life doesn't break that neatly or cleanly. So what we talked about in the previous slides was this normal kind of distribution. Well, that doesn't always happen, and we'll show you some examples here in a second. You can have bell curves that are positively skewed. That means that there's outliers here on the positive side or outliers here on the negative side. Negative skews, here's a couple examples of them. This one here is interesting. This one, it took a survey of the number of applications that people submitted before they were hired for a job. And you can see that 3, 4, 5, 6, 7, there was all the way up here to 11. And then afterwards, the number of applications started to decline before the person either gave up or found work. But this is called a negatively skewed curve because there are some people out here, the outliers, who got jobs right away. In the same token, there are bell curves that are positively skewed, and we gave the example of one earlier. Here's the same kind of a graph where income is skewed positively. That means there's just a few people who are way out here being paid quite well, a lot of people not so much. And if you just were to take the mean score, it would be influenced by that. So this is a positively skewed bell curve. Now the bell curve is not without its critics, and there are significant controversies about the bell curve. And what the bell curve can do is tell you something about a population group. It can tell you about a different ethnic group or a gender group or a a class of fifth graders, sixth graders, and so on. Now, the controversy comes in that it doesn't tell you anything about any one individual. You can't say that because of a group of people scored this way on an assessment of any kind, that any one person in that group scored one way or another. And there may be a likelihood one way or another of a excuse me, of how they might have scored, but there's no definitive way. And because of that, the bell curve can actually be quite oppressive. If you're not a typical member of a group, if you're an outlier one way or another, there could be a stereotype or a generalization that would be unfair. This is good for us as researchers to always keep in mind. If you're doing quantitative research, it does have its limitations. You are just finding out tendencies and typical kind of scores on things that tell you really nothing about any one particular individual. So we go through our work as researchers using quantitative research, always need to keep in mind the limitations of that research.